Appreciate that very much. Do you go by Chris or Christopher?
Chris is great.
Chris. So Chris Bloom is here to talk to us about Elm, which I'm super excited to hear more about. I've taken like this tiniest of looks at it. Seemed really, really cool. So
it's very niche.
It's going to be awesome.
Okay.
So let's give it up for Chris Bloom.
Cool. Thanks, guys. Thanks again, Surescripts, for having us out. Really appreciate the space. And hi, I'm Chris. I'm not a JavaScript developer. I work over in the Drupal space a lot more. So I'm in the PHP and the CMS world. But I want to present on Elm and JavaScript kind of from that perspective. So I want to get a quick feel for how many here in this room are using TypeScript or strongly typed JavaScript on a day-to-day basis. So you guys are in strong types. And a few that aren't. Anybody in anyone using, say, React in this room? Okay. Anyone using Angular in this room? Okay. All right. Good spread. All right. So this presentation is going to kind of be from the perspective of someone who doesn't get to use strong types when they write JavaScript on a day-to-day basis, and sort of our exploration of Elm and what it can provide us. So we all probably know that when we go to kick off a brand new JavaScript project, we have a lot of decisions that we've got to make, right? So we kind of look in and we say, I need a good package management system. I'm, of course, going to use NPM, but maybe we decide to use Yarn because Yarn does some very particular things for us. That's great. It's a little bit faster, potentially. We're generally going to need to choose, like we just said, some view layer, some virtual DOM layer to then work with. If you want React, if you want whatever maybe Ember's using right now, you can kind of mix and match and choose your own. We then get to choose our choice of data flow projects. If you're already in the Vue space or the Angular space, those are generally chosen for you, though you can plug Redux on top of other things like Angular 4, right? Redux is great. There's a lot of flavors of that sort of Flux-based architecture out there. All right, so okay, we're going to add some more Legos onto this stack here. Immutable data. Anyone here working in immutable data structures as a first-class citizen in your project, right? But you've probably heard about it, but not actually using it, right? Well, hey, let's drop immutable JS right into this project and use this so we've got a lot of safety there with immutable data structures. Okay, let's add some typing. If you're already in the Facebook world, maybe we throw Flow on there, or maybe like this group, we throw TypeScript on there. We make those choices very early on. Okay. Can't do anything anymore without a really good Webpack base. However, there's Brunch, which is a really awful name, which kind of works great in the JavaScript world of naming conventions. But we need some kind of build tool involved as well. Let's throw on transpilation and linting, right? Babel's pretty much the only game in town. I prefer an Airbnb style guide. Maybe you have your own, right? A lot of choices, a lot of moving parts, a lot of things that we click together. And when we go from one project to another project, we kind of learn what worked, maybe didn't work before, and we tweak it on the next version of the stuff that we build, right? And we have to wire all of this stuff together and kind of get it to work. And half of getting started with a modern JavaScript project is getting things to work together and to play nice, and all of that Webpack configuration. Who here has spent an inordinate amount of time configuring Webpack for a project, right? Maybe a little too much time, okay? Right. If that's kind of overwhelming, now this presentation is made for maybe folks that aren't as experienced with TypeScript and JavaScript as you guys are in this room, but it is overwhelming no matter what you're doing, right? And that's because in JavaScript world right now, we can do whatever we want, right? We have almost no bounds given that we've got JavaScript at the file system level, and we've got JavaScript in the browser. But of course, the downside to this is that you can do whatever you want. So if you've noticed, most of these structures that we plopped on top of JavaScript, these were all sort of to protect us from JavaScript, especially things like immutable data structures and Redux, right? These are to bring discipline and to bring fences that keep us working in a particular way inside of JS, because JS don't care, right? I've always been searching for like the one true way, right? I work in teams and I have to deal with training people on how stuff works. And often when I'm training someone on JavaScript, they ask me, well, why this way? And it's usually just like, well, that's what I configured 6 months ago when we started this project. I like to offload the responsibility of a lot of these decisions to maybe a structural and systemic system that was there before I got there, some highly opinionated system. And guess what? There is a highly opinionated system out there already that really handles a lot of this stuff. I like strong opinions, and I like strong opinions especially when they're proven to work. So here's some of the things that we have to kind of worry about, right, when we're dealing with JavaScript. Some of the things that Elm goes to address, right? Null values. Who here has seen undefined is not a function in a console? Okay, if you're not raising your hand, you're lying right now, right? Mutability, right? In any function, I can screw with any enclosing scopes value. In JavaScript, everything's mutable in JS, unless you're using CONST and ES6, but we'll get there. There's a lot of unsafe APIs in JavaScript. I get values. Sometimes when I call via AJAX to something remotely, sometimes I get stuff. Sometimes I don't get anything, and we have to write a lot of guards and if checks around that, right? How do we make JavaScript safe? That's what Elm's going to do for us, and Elm has this wacky promise that a lot of like older, crustier developers think is total BS, but they promise no runtime errors in practice, okay? And they also promise, well, they have built in, there's no such thing as a null in Elm. You can't write null. Null's often been called the billion-dollar mistake by Seth Ritchie, I want to say, right? One of the founding fathers of programming. Null having a value that isn't a value leads to a whole lot of edge cases and problems, right? And of course, we no longer have undefined is not a function in Elm because of its structures. So we're going to kind of dive into like what Elm provides, what its syntax looks like, and to answer right now, yes, Elm compiles down to JavaScript. That's it. It's just a language built on top of JS. Any questions? Feel free to interrupt me if some of this sounds crazy or silly. Ask me anything. We good so far? All right, guys. So here's what we got with Elm. Elm promises a blazing fast virtual DOM. It's actually the fastest virtual DOM out there. When you see the syntax, you'll understand why. It's because there's nothing pretty put on top of it. It's just a whole lot of functions. You can only work inside of immutable data. That's it. You can't overwrite values once you set them in Elm. You're forced to copy, change, and return. Everything is static typing. I thought that was really appropriate for this group. Thanks for letting me talk to you guys, because I don't get it right in TypeScript, but I know you guys understand the value of static typing. When I show PHP developers static typing, they think it's just a whole lot of extra work on top of JavaScript, right? Elm has a unidirectional data architecture, and what I want to clarify what that means is Elm did Redux before Redux did Redux. As a matter of fact, in Redux's documents, they credit Elm for the inspiration for the project. Everything is purely functional, and we'll get into the details of that, but what purely functional means is everything's a function, it takes in arguments, and it returns output. That's it. There's no side effects. One function cannot affect anything else in the system. It can only return values. Elm has semver as a first-class citizen. Before you're allowed to publish packages onto Elm, you are forced, it parses your work, checks the differences between your prior version, your new version, and then auto-increments your semver version if you're changing any contract in the API to the package that you initially published. Long story short, it handles semver for you, and it's very strict about it. The compiler for Elm is really great, helps you out. It's very helpful. It's got really good output. And there is a code formatter companion project that works very closely as you work in Elm and really helps auto-format your stuff. It's great. Like we said, it is JavaScript, runs in the client. The syntax is very tall and spaced out and really, really expressive as well. So that's a lot of goodies, and it seems like it's too good to be true. So let's just kind of dive into sort of what Elm looks like. I like code in presentations. I don't like talking about code. I like seeing code and kind of working through what it's actually doing here. So everything in Elm is a function, and I've tried to show the rough equivalents over in JavaScript on the right-hand side or JavaScript with frameworks on the right-hand side. So let's add, right? Let's make an add function, right? In JS, you've got function structures, you've got squiggly brackets, and you've got explicit returns. You don't have to return anything in JavaScript. You can just have a function that like does stuff, right? Incredibly dangerous. So everything in Elm, as you can see on the left-hand side, is implicitly returned. So you're going to see an add, argument 1, argument 2 equals implicit return num1 plus num2. you don't get to not return in Elm. We've got say woof, which is some simple concatenation. As you can see, say woof function name, argument, and then concatenation with plus plus and strings. Pretty straightforward, really elegant, super, super clean. Right, we've got our implementations down on the bottom there, add and say woof, right? Pretty cool. Any questions on functional syntax inside of Elm so far? Rock on, guys. Let's look at what pure functions mean. Over on the right-hand side, I've specifically declared a var with let. Let lets us change the value of a var after instantiation. So I've got mutate me right there as 7. I've got some function that then just goes, changes mutate me, and returns mutate me. Okay? So now when I run mutate outside, it returns 8, but I've also modified the value of mutate me to 8 as well. We've actually messed with something outside the scope of our function. In Elm, we can't do that. We don't have the ability in the structures that are available to go mess with things that weren't passed explicitly into the function. Okay, so we have mutate me, 7. I'm trying to mess with mutate me right here, right? Hey, I've added something to it, except we're returning this value, so the original value is always there. If I ever want to keep adding on to that and aggregating those values, I have to keep calling output from one as input to the other, makes output to the next thing. Cool, all right, pure functions. Anyone work in kind of like a purely functional paradigm? Everyone come from Haskell? Any Haskell old? All right, a little bit? Okay, all right, you get it. Sweet. Let's talk about, this is just a simple kind of contrived example of like the declarative nature of Elm. I'm a really big Lodash fan and those kind of helper utilities because of the way they allow us to compose functions together. But in Elm, I just want to point out, you know, nice, simple, clean syntax on the left-hand side. Let's see how we'd say, take a price list, iterate over it, add some kind of mutation to those values, and return the new collection, right? And you can kind of see what we've got over here in the markup inventory, how we're looping through it, we're adding things onto an array, and then we're returning that array back. Okay, not crazy. Yes, you could probably write this way cleaner and way more elegant with the right techniques. But on the left-hand side, okay, let's declare a list. It's an array-like structure. It's not an array. We've got a function called price. We've got a markup inventory that takes a list, okay? And we're going to just run a map against the list, running it through the make profit function, and then we just say markup inventory with a price list, and we get those values back, right? It's very, very Lego-y, and I like that. I like being able to declare functions and click them together into these kind of results. Any questions so far on that syntax? Looks kind of weird.
I'm curious why the reverse of the function and then what's passed in the function.
Right. So list map says, okay, I need a function that I'm going to run against stuff, right? And so you say list map. It takes a function. I'm actually going to talk about.
So it's just like the parameters.
It's just the params.
Okay,
That's
the parameters
it.
Just function and then, okay.
Exactly. List map is a function that takes 2 parameters, a function and a thing to run it against. Now, you actually just hit on a perfect segue into the next thing, and that's the concept of currying.
Continue later.
Okay, all right. My plant in the audience. So, who here has had a chance to work in currying? If you've ever used Lodash or underscore, they actually have currying libraries built into them that are very, very cool. Think of it like this. Let's look at it in raw JavaScript on the right-hand side. We're going to have a baby animals function, okay? It's going to take one argument, but what is it going to return? It's going to return a function. You guys are actually probably using currying more often than you expect in the libraries that you're using, the frameworks that you're using. But we're returning a new function that's essentially preloaded, right? We brought into scope the A argument. The function we now have is expecting a B argument, but it's all preloaded. So I'm going to call baby animals, I'm going to send in koalas, and now I have a baby koala function that's ready to take in anything else we get it, but it's preloaded, right? This is how we compose. This is how we get compositional programming in a purely functional paradigm, right? And we load these functions up with these sort of initial values, right? So we call baby koala with puppies, kittens, pandas, and you can kind of see the results there. It's pretty straightforward. Now, of course, in JavaScript, if you double paren, you can get both, right? Because we've got the implicit output of this first function, okay, is then being called with this function, right? Paren, paren, 2 things. If we had 3 levels deep a function, we could just call it with 3 full parentheses with arguments being passed in. Right? Now, on the left-hand side, I want to point out that everything in Elm is curried by default. You don't get to not curry in Elm, and this is insanely powerful. Let's look at our baby animals. We take in A, we take in B, and we say, I love thing and thing. No returned functions, right? No initializing of setting up of, okay, I've got some value, now I have a new function, I'm going to go call it again. Or rather, the initialization is a lot simpler because all we do is we say baby animals, and all we do, if we do not send all of the arguments that this function expects, Elm says, whoa, you didn't give me all my arguments. I'm not going to give you back a value or end up with an undefined value. It returns back a new function that's just waiting to get the next set of values built right in. Now, this is really cool because it allows us to build a much larger function from a lot of smaller things as you sort of build it up and get it preloaded with stuff. And you can see, all right, now that I've got baby koalas, I just call it with the rest of my parameters, and that's just how Elm works out of the box. Everything's a function in Elm. Everything. Very cool. Cool. Any questions on currying? All right, guys. You guys know what you're doing. All right. Piping. I really, really, really like this form of coding in JavaScript. I really, really like the chain concept in _, and we can get this right out of the box with a pretty stable library. We're going to make a new list. We're going to run this chain function, which says, cool, let's run a bunch of mutating functions against this chain, and then at the very end we'll pop out the final value. So I'm going to run my list against, I'm going to make the list chainable. I'm then going to map against an inline function. That's just a nice simple ES6 inline fat arrow function. Okay, it's going to multiply it by 2. We're going to filter out things that are greater than 6. And then we're going to just run it through map again and make an exponent. And then at the very, very end, we're going to get the value out of the thing. Okay, pretty cool stuff. Really great way to code in JS. In Elm, chaining is just a first-class citizen. It's just how Elm works, right? So we're going to define a list to start with. We're going to say list.range. Gives me a brand new list that I can iterate over. And then we just use this arrow greater than symbol, and we just pump it through Elm's inline function syntax. Now, you notice this little backslash arg, backslash arg, arrow, arg, and then what we're going to do to that argument. This little backslash is a little homage to lambda. Anyone know the lambda symbol? Anyone play Half-Life 2? Too much, like I did in high school? Okay. So the lambda symbol, that's kind of what they're trying, because a lot of functional programming has roots in lambda calculus. That's the callback there to a lambda. So essentially a quick inline function, just like we would do over here with fat arrow syntax, is how we do it right here in Elm. And all we're doing is we're just chaining this value, and the output of one becomes the input to the next thing in the chain. And then when you're done, boop, there we go. We get our results out the other end. I really, really like this, especially when we're dealing with large data sets, maybe coming from some API we don't have total control over, and we really need to reduce and filter out those values. Being able to do it in Elm is insanely popular, insanely positive experience. Okay, any questions with piping in Elm? So far, so good? Cool. Now, what we're all here for, actual static typing, because this is kind of in your realm. So Elm is both purely functional and statically typed. This means that Elm will yell at you a lot long before you're able to go, you actually can't even compile. Long before you're able to actually get this into a runtime, it's going to blow up anytime you try to do things that don't meet its typing contracts. Okay? You can see right away, right, if you explicitly state your variable type, Elm's totally cool with being able to accept values for that variable type. Now, it's really good at inferring. You don't have to do this for a lot of the primitives. Strings, booleans, numbers. It's pretty good with just being like, yeah, you don't have to tell me this is a number. I can tell you're giving me the number 1 on it. But if, right, we can start chaining types together. This is a concept, of course, in TypeScript already. Right, so I have a list of ints, for instance. Now, as you can tell, in Elm, you can only have lists of a single type. You can't mix and match types because of the strong contracts that they're trying to set here. Functions also have type signatures, right? They have an argument type, and then they have a return type. As you can see here, we've got, say, meow takes in an animal, and the animal concatenates out the value. Now, if we try to call, say, meow with an integer, things are going to blow up because I can't just concatenate a number onto a string in Elm because it's not going to make that inference for you. You have to do it very, very manually. It's not going to do type conversions for you without you telling it to do that. You can see down here that we've got this multiple arrow syntax. This comes back to currying from before, where I have a function that takes in an integer as one argument, an integer as a second argument, and finally returns an integer. Okay? If I call add with only one argument, I have a function that takes one int as an argument, expecting to return an int as the ultimate value. Okay? Very, very cool stuff here with this. I'm not super familiar with TypeScript's type syntax. Can someone kind of fill me in? Is there rough equivalents to these kind of declarations in TypeScript?
Yes.
Okay.
Quick question though.
Yeah.
What do the numeric types look like in Elm?
Okay, so we have integer, we have float, and we have lowercase n number. When it can't do an inference, if you give it, say, 2, it's like, that's a number, that's not an integer, because it's not going to make that inference that it is just an integer. So it will infer to a generic number type, not just an int or a float. Cool. Sweet. I come from a world where we don't really have good compile time type checking, so that blew my mind, right? Being able to see that kind of stuff in action and be like, wow, it's saving me from my own stupidity long before I push this up to production. Okay, so we're going to get into union types and records, which are just the rough comparison to objects in JavaScript. So we are going to have we're going to declare and use a union type. So we've got this disposition, right? It can be one of 3 things. Okay, we've got surly, friendly, and ambivalent. And then, of course, in my record type, cat, okay, this is called a record when we use this structure. I can then go just use that union, and I have a very tight contract of what a cat can be. All right. Of course, besides a name, a weight, and then disposition. Who here in the room can tell me what my values that my cat disposition can possibly be? It's pretty straightforward. Anybody? What can Seamus be disposition wise? Surly, friendly, or ambivalent. Right? Okay, pretty straightforward. But right, if I tried to make his weight a string, it'd blow up. If I tried to choose some random string for disposition, it of course would blow up at compile time, long before we ever put it into runtime. So we can then access values on records by record.name, record.weight. Now this is what's really crazy about a purely functional programming language. I can then pop off any of the key values of the record as a function and then send it in the object as an argument and get back the value that I want. Yo.
Quick question. Disposition is a type.
Yes.
You're using it as a value.
So, explain that.
We don't get that in TypeScript.
Right. And this is the difference. This is the difference that Elm takes to this approach, right? Now, the side over here, so in Flow, anyone here worked in Flow very much? I'm sure it's kind of similar a little bit to TypeScript, right? We get the same values inside of Flow as long as our string meets this contract, right? So I have surly and Flow's like, cool, do that, right? The way these types are defined in Elm, they're essentially variables with values preloaded, right? They're actually functions under the hood that are expecting to be given an argument and return the check on the type.
So that works in TypeScript now.
I was going to say that should work.
Yes.
I'll use that
Yeah.
all the time.
Any value can be aliased as a type.
You notice the alias, right? Right here, right? So there's the difference between the type and the alias. And you're going to notice here that my usage of surly, not a string, by the way, right? This is a symbol of surly.
Right.
It's not a string value of surly being used as a value there. Cool.
So it's like a kind of automatic enum in that respect?
In a way, yeah, think of it that way, right? Okay.
Could you have strings where it can be one of these strings kind of thing?
Yes. I mean, of course, that's what we're doing technically up here. But yes, you can have a type alias of, well, essentially it'll act as this join up here, or as this union type up here.
So I know in TypeScript you can do it by the like actual text. If you have an enum, you can do it by the text alias, but it's actually representing like the number, like either 0, 1, 2, 3 of the enum.
Oh, of the enum. It's
Yeah.
essentially a key position
Exactly,
on
key
a, okay.
position on that array, which gets really bad when you're trying to rearrange them.
So that's the enum type, but they support this syntax as well.
Yes, exactly.
So-
Yeah, I was going to say
Okay.
this, and then in that case, it would be a string that you would assign, and not the actual object. Yeah.
Exactly.
Quick question about that last line down there, where you're calling the setter for name. How does it know that that name refers to name on the cat?
Okay, so because everything's a function, that name right there in this scope, right, in the scope that we're working, consider this as being a module inside of another larger. You're probably thinking immediately, aren't we going to just, like, how many things in this I'm going to have a name on, right? Like, what if I have a cat declaration here and then I have a person declaration, both have a .name? Yes, you're going to end up in a collision, and you're actually going to result in a compile time error right there. So that's why Elm is highly module architecture. So anytime you're declaring types like this, it's recommended that it exists as its own module that you import somewhere else.
So if you had a type dog that for whatever reason didn't have a name property, would that still work, just .name like this?
I don't know. Actually, I do know. Elm will yell at you because it's going to check immediately if that name is a member of this type alias cat.
Okay.
And we can try it. Actually, we'll pull up the REPL here in just a bit and give some of these things a shot. So let's bring that one back. Cool. Any other questions?
And what you're passing into name there, is that a string literal?
So that is Seamus, the instantiation of the,
okay.
yep.
Got it,
So Seamus is of type cat. I'm expected to meet this contract. So now I've got a var, right, for all intents and purposes.
So you're actually calling the getter, and you're saying call the getter
against
on this type against this instance.
Bingo. Yep.
Okay, got it. Thanks.
All right. So a little bit more on type aliases, and let's talk about immutable data here really quick. So we're doing a couple of things together. We're mixing and matching them. All right. We're back to disposition, right? Surly, friendly, or ambivalent. Now, let's make 3 cats, okay? And I go on vacation, and our house sitter is taking care of Seamus, and overfeed Seamus quite a lot. How do I modify Seamus? I actually never change. I can't mess with any of these values anymore. They're frozen in time forever. What I have to do is I have to take the value, pipe it through a key change, and return an entirely new instance of Seamus, right? And so all I'm doing is I'm multiplying the weight by 1 against Seamus, and this syntax with the brackets here is how we do that very, very quickly and elegantly. And now I have Piggy Seamus, right? So he now weighs more, but there's still an old Seamus hanging around. If you ask, isn't that inefficient? Isn't that not very memory smart? That's why we have garbage collection in JavaScript. We have very good garbage collection. And if I never have an active reference to Seamus anymore in the cycle of my application, that is swept right out of the application, right? So we don't have to deal with that junking up. So if I have a million Seamuses that I'm just making and modifying, and then I never reference them ever again in my application, they're all gone out of memory. Cool. Any questions about that? Sweet. Okay, I just thought this was cool. Probably have this in TypeScript. I'm not super familiar with TypeScript, but I'd love to know. Essentially, we've got a union that is then referencing itself, right? So we've got our normal types, but then a very special declaration, a special type called mix that takes in 2 values, and we're just going to say disposition and disposition, right? And what's very cool here is that I'm able to create 3 of my cats, and then specifically make a mix of two of them, and I'm able to like mix and match these types together. But what this means is, I think I handle this in the next thing. Okay, we got that. There's my mix. I want to see really quick if we do this on the next. Everything is function. And are we going to get these things back? If I ever want to check the value of my cat's disposition, I am now forced to loop. I'm now forced to iterate over the value, and this will yell at me at compile time. If I'm ever just like, oh yeah, give me, Seamus dot disposition, and I want to try to just mess with that value directly, I will fail because I need to handle the special mix condition now for everything, for every cat ever used. That I found to be very, very cool as well, about having that kind of type checking at compile time. Does that make sense? Mm-hmm. Okay. And we're going to see a little bit of the special check typing when we deal with maybes. Does anyone here work in a JavaScript framework that has a concept of maybe? Does TypeScript have a concept of a thing that can be or not be?
I think now with the thing syntax after the value, isn't that kind of like maybe?
I was thinking more like optional type.
Optional?
Optional arguments.
So like optional arguments to a function,
Yeah.
like functions that may have a thing or it may not. This is more like, I have a value, okay, great example, AJAX call to an API. Okay, give me all your stuff back, and then I'm going to just check the first value and explode the rest of my program when it might be there, it might not be there, right? And we write a lot of guard code to be like, if value, then do stuff, if value, then do stuff, if value, then do stuff. The only way to be able to handle that at compile time is if you very clearly declare something as it might not actually exist, forcing special constructs in Elm that force you to check. So let's walk through this really quick, right? So this is just an example of the maybe type in Elm core, okay? It takes in anything, so you can have a maybe of an int, like I'll have an int or I won't have an int. Maybe of a string, I might have a string or I won't have a string. That is just the thing if it exists, or a special thing called nothing if it doesn't exist, okay? So it goes like this. We've got a user and a name, and we don't make age a requirement for someone to fill out in our application, so they can fill it out or they can just leave it empty. Now, when we have Sue of user type fill out, she now has a nothing because she chose not to answer, and then Tom chose 24. But it's not just the value of 24, it is a just 24. It is a just type with a 24 value. A 24 argument sent to it, okay? So we have a just 24. Now, later on, we've got some kind of checks in our application whether or not we're going to sell them alcohol, okay? So I'm going to take in, I have a function of can buy alcohol, takes in a user argument, and it returns a Boolean very explicitly, right? So here we go. Can buy alcohol, takes in a user. I am now forced to handle user.age on a case, using a case switch statement, and we can switch on types. We can case switch on types in Elm. So now I say, listen, if the user age is nothing, return false. If it's just anything, literally we're just checking types here, we're not checking values. If it's just anything, then return if age is over 21 or not, right? And you can see how we do this. If I don't do this, Elm explodes at compile time and says, yo, you didn't handle all routes in your code. Thought that's pretty cool. You're going to write a lot of case switches in Elm around these kind of things.
Can you explain again what's just? Is just something that's not nothing?
I want you to know that just was something I spent a week on. Just what is just, right? Like, it was very, very frustrating. It's the idea of if we're going to have something, if we're going to have a value that can potentially have some value or just be null, for instance, just not have a value, we have to represent nothing. So it makes sense with a capital N, nothing, to be like, you've got nothing. Not zero, not null, not empty string, a special nothing type. That then means when we have the value, we need to give it a type of something as well, right? So it's going to be a just any other primitive type. So a just int, a just string. And what we do is it simply lets us do a quick check and say, does this thing have nothing? Cool. Let me ask you this. In this case switch statement, if we hid the bottom just age, how would I do a check against not nothing? how would I do a check against, are you not null, right? And the way we are able to do that check is it's checking just. Do you have a value that is anything that is not nothing? That's a lot of double negatives there, but it's essentially just a quick type that allows us to verify the existence of something, because we don't get null in Elm, and this is how they get around the no null black hole, right? Is saying if you have a value. Now, not everything is required to have a just. Only specific types where we're thinking architecturally very early on, yeah, this is something that could potentially be empty, right? And you're generally going to deal with these in a lot of like API responses as well. Cool. Any other questions? Yes, sir.
TypeScript has a strict option that makes it behave like Flow did by default.
Is it like required to have this, like strict? When you say it's strict,
yeah.
Is it like you
can't, unless you say something could be undefined or null and not undefined.
So what this means is
you don't get to pass or not pass.
So this means is at the creation of that thing, you have to ensure there's a value there, right? But it's not necessarily this could be empty, and then our checker, like, so it's sort of like, when do you check for nothingness? Do you check it at the return from the API, or do you check it later on after the API has potentially been parsed? So it's sort of like pushing that decision-making process to sort of maybe later on in our application, versus when we would make a user, for instance, I would say very clearly, instead of nothing, I might have to say empty string here. You say Flow does this too. Okay.
Well, if you don't allow undefined at all, you have to provide a value.
Have to have something, right? Now, and a question here is an empty string nothing? Because I can do a dot length on it. I can concatenate it onto other things. You know what I mean? Like it's one of those very interesting things of, are we then forcing essentially type conversion at that point? Yeah. Okay. Yep. There's our ints and our nothings, and cool. Oh, sorry. Yes.
Sorry. When you make Sue, do you have to have the comma age nothing at the end?
Yes. You can't create Sue without filling in all fields, right? And Sue has to, otherwise compile time explosion, has to be either nothing or just a thing. Now, because we declared the type, it has to be just an int, period, right? Instead of just, if I try to do just hello, right, in a string, it would explode, because it's like, no, maybe you're doing math on this, right? So I'm going to blow up long before you ever even get to a type check. Cool. Okay, a little bit more of maybe. All right, so I really, really like this, because this was the mind melter for me also of, I have a list. I don't have a guarantee of anything in a list. Okay, the list can be empty. So lists, you're not in Elm. When I was like, I just want to iterate through this list and print some stuff out. Elm's like, nope, you can't do that. You have to check if this thing is empty before you're allowed to use this list ever. It's at first annoying, and then later on you're like, this is so wonderful. Everything is so safe. So we've got a list we've defined that is a list of strings, just like there is a just of anything of ints. And what we're going to do is we are going to get the first thing in a list. So that's a list.head. List.head is a built-in function to Elm, which is just like saying, hey, array 0, right? Now, I'm going to give it my list. And here's what's crazy. I can't just say list.head, my list, and then take the value and roll with it, because it might be nothing. So this is a really good case inside of Elm where they just use this kind of concept out of the box. So we say, okay, I am forced to do an of check. If it's nothing, I throw an error, I break, I console log or something. And someone is totally calling me. 1 second. So now, when I take the just value, all I do is return the value, right? Because that's what I actually want from my list.head. All right. Does that make sense right there? That's kind of one of those examples I was like, oh, list can be empty. That makes perfect sense. Okay, sweet. In the JavaScript world over here, right, first and second, list 0, cool, let's run it. Or my list is empty, boop, undefined, an error very, very easily, and this is one of the main errors I see is just checking to see if something's there and it's not there, right? Because there's no guarantee that we're always going to have something, especially if we're dealing with pulling in values from outside our application. Cool, cool. Any other questions? Sweet. Cool. Just a little bit on the Elm architecture. We're used to, so Elm has tooling for all of this stuff. They have their own package manager. Okay, they have their own compiler. They have a runtime, which is really, really awesome. I'm just showing what the equivalents would be over in the Node world, okay? And there's a full dev server, right? Built right in. Of course, we use Webpack dev server for this kind of stuff. But Elm, out of the box, and all you got to do, npm install -g Elm, and you get all these goodies ready to rock. We get all of these things. So last but not least, we're just going to talk about the Elm architecture really quick. For anyone that's familiar with Redux, this is going to look really super familiar. All of this is part of the Elm architecture, the tooling and the data flow model here. Who here knows Redux or Flux and has messed with those things before? Okay, what is the kind of the core concept with Redux? What's like the one thing about Redux that makes everyone go, oh yeah, that makes sense? How does data work?
You don't change the data.
You don't change the data.
Copy it.
And it goes in one direct. It goes in the top, straight through our thing, and then pops back out and goes back in the top and goes straight down through. We're not changing a bunch of things all over the place, right? We have, it's not like Angular 1, anyone comes from that world, where you're just changing, you had controllers and models, you're changing them all willy-nilly all over the place. No, we change values and we watch it cascade through to a view and then ultimately into rendered HTML, right? And of course, this might look familiar because it's basically the exact same thing that Redux does. It says, okay, you've got state, depending on what that state is. Some UI logic runs depending on that. Some actions can be triggered. Those actions fire what are called reducers in Redux, and they just kind of melt all of our changes down into one thing. And this modifies, or it updates a store, and stores contain different pieces of state. Okay? And this is where Elm kind of comes in over top of this stuff and says, yep, I'm just going to handle it with my view and my HTML. Elm has a concept called messages built in that does this, an update function, and a model that does all these things. This is just how you write Elm programs, okay? So you can't not use Redux when writing Elm applications. It's just how you do it, which I found kind of refreshing because it's like, hey, how should I build this application? You're using Redux now. Real quick, all you do, right? We're going to click a little button on our little tiny application here, right? It's going to produce a message of a value of type message. The message is going to be piped into an update function. The update function also produces a new model as output. And then we have a view that is subscribed to that model. And then as the view changes, the HTML changes. Long story short, when we're wrapping up here pretty quick, but if you want to check this out, this is on, I'll put this in your, do you want to grab this for your Slack? Hang on. And we're going to do, hang on one second. Can you dump that into your Slack channel if people want to hop onto it and check it out? I know it's kind of a wacky number there, but we can pull this up in an online Elm coder called Ellie, which is really fun to use. It means we don't have to have any tooling locally, and it just looks like this. So here's our little button. I'm going to zoom in a little bit so we can see it. Okay, it's just a little boost. What's that? Oh, jeez. Okay, I'm going to mirror directly so you guys can see it. Oh, geez. Okay, can you see it now? Like that. Okay. Sweet. So if I change my values here, we're going to walk through a little tiny program on the left-hand side so we can see it in action. And I'm actually going to pull this up in VS Code so we can see it. Okay. So, by the way, here it is hosted locally. I do want to pull up the history so you can see it in real time. If you've used any Redux demo tools, I'd like to point out that there is a model value of 0 here. I know it's very, very tiny. I can't zoom it in. But as I increase my value, you're going to see the messages that are going through, and then our decrement messages as we go back, right? These are tools that are built into React and Redux. We're probably used to those today. We also get those with Elm as well. So really quick on the code, and we don't need to spend a whole lot of time because we're kind of right at the end of the hour here. But all we do is we define a program. We have a main value that it takes in a program type, a value I've never actually understood what this does, and then a model type and a message type right here. And what we're going to do is we're going to return back to it a beginner program that's going to take in a model we define down below. You can see a type alias of model. We're just saying I have a model variable. It's going to be an integer. That's all. Okay. I have a view, which is a function, and I have an update, which is a function. So let's take a look at our message type. Okay. If anyone's written any Redux, you know that you define the type of actions you can do in Redux. This is the same way. I can only increment, I can decrement, or I can set an explicit value, which is a string. Okay, so my update function takes in a message, takes in a model. This is all wired up for us essentially, where we're able to actually go and say, okay, I have message, I have model, and they're all glued together for us in this nice little helper function that Elm provides. All we have to do is provide the structures, and Elm will wire them up together with this little nice beginner program. Okay, so here's our message. And these are just symbols. There's no special value here. I could have called this kittens, and this puppies, and this herp derp right here, but this requires that we give it a string. So when my update runs, it's given the message, and then all we do is we check the type, and then based on the type, we do different stuff. And you can kind of see here, I'm going to increase my model, and I'm implicitly returning a function because everything's a function in Elm. And if I'm given some value, I'm going to cast it to an integer, and once again, Elm strikes again. What if I tried to cast something to an integer that doesn't work, that doesn't become a number, becomes some garbled mess? I have to check to see if it's okay or if it's an error, and let's see that in action just really, really quick. Okay, so we know decrement works, we know increment works, and we know that 7 works. All these things make sense. Now, if I try to put in the word kittens, I'm typing lots of junk values here, as you can see, but it's not changing because I'm attempting to put a string in that doesn't convert to a number very well, that can be converted, that can be input as our actual, that can change our actual model value. Okay, so that's that in real time, and all of this happens at 1,000 times a second. Okay. Any questions on that code? Yes, sir.
So you explicitly set the value to 0 when
Yep.
you could have read in the current value and just remain.
So so here's the thing. Can my let me check to see if we can do this, right? So I have a message that's sending over a string. If my value comes up, no, here's why. No, I absolutely could have done that. You're right. I could have kept that as the value kittens if I wanted to, because there's no checking on the UI in the HTML. Okay, so we could have set that. Yeah, and then down here below, every one of our view functions is sent the current state of the application, and we are not even going to get into this right now, but this is how you write HTML in Elm, and it's pretty gnarly. Makes a lot of sense when you do it a little bit, but just think of everything here as a function with args, and then attributes, values. So 2 values, attribute, value. Well, more like value. Okay, attribute, value. Divs, spans, buttons, they all become functions in Elm, and you're going to notice that we actually import them right up here, right there. Okay, we're not importing button things, we're importing a function called button that is expecting to generate HTML for us. Okay, so define a model, define your messages or actions in Redux, and glue them together in this beginner program and let it do its job. And you can start getting a whole lot of functionality out of Elm very, very, very quickly. Yes?
Where's your style sheet or whatever that says what input group is and input group button? Like,
Right. Okay, so this is me setting classes, and then I'm totally cheating by including the Elm script, and I'm pulling in Bootstrap on top of this, right? So this also gives a good demo of Elm as just a JS binary sitting somewhere else that is then used in a bigger scope, right?
But you can export into as HTML, right?
So Elm must control, and you're going to see this right here. We're going to grab our little DOM node. Okay, I'm going to grab main right here. Okay, and then I'm going to say, yo, Elm.embed inside of main right here. It's exactly what React does. React, you fire up React and you say, React, go stick to this div. And React's like, cool, I'll stick to that div. And then everything inside that div is a virtual DOM soup that we don't ever get to access from the outside necessarily. Cool. Any other questions? All right, right at 55-ish minutes. So thanks, guys.
Thank you.
I guess the one thing I'd add.
Yes, sir.
For people who are interested, a year or so ago I did the Pragmatic Studios stuff on Elm.
Oh, cool.
It was really, really well done, and they've kept it updated. It's currently updated to 0.18.
Pragmatic Studios? That sounds really, 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 really familiar. No, I have never seen this before. This is awesome. Ooh, they have Elixir too.
The whole thing. I mean, I spent my Christmas vacation going through it. It's very, very well done. They've done a great job of keeping it current.
What would you say was your biggest revelation working through Elm stuff?
I'm not sure. I really enjoyed the cleanliness of the model, like the whole being able to define things and have stuff not break in runtime. I guess
having it like watch out for you, right?
Though at the time, I have to say, I stopped following it for a while because I'm like, how am I going to get work doing this? So like, oh, that was fun.
Oh yeah, ain't no one hiring Elm developers back then.
Very interesting. Well, it's different now.
Yeah,
Right?
yeah.
They did the Google Summer of Code. They joined Node Inc. I mean, there's a variety of good things going on in the Elm world, but I still haven't seen it leak out into anyone's job postings yet.
There are a few really big Elm projects. Like if anyone's used Pivotal Tracker, it's an agile project management tool that's really, really, really good. They're the largest Elm project out there on the web right now, which is super, super awesome. So, cool. Micah, you want up next?
Sure.
All right.
We're taking a little break first?
Yeah. We'll take 5 or 10 or whatever, stretch your legs, get something to drink, get more food to eat. Some time to switch over presenters.
I don't know if I classify myself as a React programmer, but I've kind of dropped into it because that's what the project already had.
Yeah.
So I thought it's UI experience I came from.
Thanks for letting me.
Chris.
Thanks for letting me blab. I appreciate it. Thanks a lot.
for coming and talking. That's awesome. Very cool.
Yeah, this stuff is pretty rad. Okay, let's see if I can catch.
You have plenty of time.
I got lots of time. I'm gonna hang for just a little bit. I'm gonna bounce before we get on to the before.
And it was all over the library, all over the place. jQuery was like for old people.
And all of a sudden, I became obsolete just by blinking my eyes. What the hell?
We're relatively new.
A lot of the out of the box stuff for jQuery was cool. Like if you wanted to try and use somebody's library, and like that table stuff was a nightmare. I tried to use somebody's table and for like
that was pretty handy.
and all stuff, and every one of them was just one different version of crap.
So
I mean, it just sucked. It sucked. Like to the point where like you're at that point where like we should have just written our own. I'm like I could have done it just by using a table, HTML, and some JavaScript, just plain JavaScript. Like, I came up here and I picked up. I don't even know what it was. They were like, I interviewed and they're like, "Oh shit, you're not going to program for a while." I'm like, whatever. And then everything flipped around. Here you go.
Functions, I guess, is a whole bit of function. And then I post on it.
Oh.
We're far enough. Oh, really?
And had some interactive and we jumped right into React on when we had all the just so that was in the beginning. That was it started
Nice to meet you, Micah.
Yeah, nice to meet you as well. Appreciate having me.
Thank you for volunteering to give a talk.
Now the question is...
Oh, it's this one.
Well, yeah, but do you have Minity?
I've got one.
But not used to actually having just the straight HDMI in the table. Yeah, if you've got one, yeah. It's the one adapter I guess I don't have.
I've got the same.
Very nice. You know how it goes. Yeah, at Microsoft campus, they've got like every single projector is like has a dozen, just a snake of things you can plug into, except for USB-C, which is kind of annoying because I initially had an XPS 13 that had USB-C for the output, and I was like, really, the one thing they don't have. Hey, Chris, is this yours? Okay. Outside. Hey, we'll get you on PC by next time.
Oh my God, Mike! What have they done to you?
They're giving me a beautiful machine.
That is a very, very pretty laptop.
It is really pretty gorgeous.
Is this the Surface? It's the Surface.
Yeah. My favorite thing was I had let me log in first. I did a workshop a couple weeks ago on creating a design system out of a Vue app. So I took like the basic Vue to do app. It's totally fun for teaching too. And I took the UI and did that, and then flipped it around and just started drawing on it. I was like, oh, come on, yeah, bonk. Well, because then you can do this action, and then go like that, and then you've got a sweet service right now.
That's amazing.
Yeah.
Wow, how long have you had this?
I've been using it for the last 4 months or so. Unfortunately, this is, for some strange reason, Microsoft isn't great about giving their devs powerful machines. This is like an 8 gig like original service book. I'm like,
as long as you're not running like any virtual machine.
Yeah, it could still be better.
I'm sorry.
Anyway,
I missed your presentation.
Oh, it's a short one. I'll have a better one in the future. But yeah, good flight. Where are you heading off to?
San Francisco, right?
Rough time. Enjoy. Oh, nice. Hurrah. These desks are too angled.
Yeah. I often find myself grabbing a table and sitting at the table when I'm doing anything work, you know?
It doesn't work. For the most part, that's fine.
There is. Maybe we'll leave you a Yelp review.
Alright, which? Oh yeah, I'm on the screen. Let's kill these things. Actually, let's.
So your last name pronounces
As you hear it, yep, just Godbolt. Close.
And there's like lazy loading that yeah, I don't have to push a huge number required. I don't think that's the I use it on
Oh, huh.
So you have to do bootstrap based on every once in a while.
What's the Wi-Fi in here? Does anyone know?
Connectivity, lowercase c.
Is that
I
the?
haven't gotten to that. Tutorials and
Oh, it's just Guest Network. All right.
it's there in my list because I
Lowercase.
Yeah, lowercase.
so
See if I can spell. I was like, why didn't it load? Oh, yeah. I guess I need to connect first.
I didn't have to do it if that import stuff to work. Just create React. Just do it. And that's what
Oosh.
their CLI does. we go, was it ng new, name your app, and there's your app, and it runs. You know, ng can start, your app's running on 4200.
Do you know that we create React app, upgrades happen?
Yeah, just this.
Yeah, that one.
React app. So I get this like it goes live.
The hardness is
Getting
free t-shirts is getting
yeah, yeah, you have to update
I
the.
never had like the right sounds.
When they first started our project, they
We get the extra large.
branched, it's really extra large.
Or they say it's extra large
So,
and it's like.
Ejected.
Immediately,
That's what
yes,
they
basically,
ejected.
well, yeah, it immediately went, you know, to where it broke the whole.
That's too bad.
Yeah.
That loses the.
There's a lot of stuff added in, you know.
Yeah, they call it ejected. I would not have to eject.
Well, it wasn't technically ejected, but instead of using React scripts, it was using a forked version of React scripts that didn't maintain sync with the main branch. So, yeah, but they had to do it for some reason or something. I don't know if I was sure. At the time, React was so much easier to work with. And then, you know, a year and a half later, Angular. They made it easy all of a sudden, because at the time it was just Angular 1. We didn't want to do that. We're already doing backbone. We're trying to get out of that backbone.
I did kind of a decent size app in React without Redux. And then I could do another version of it.
Set?
I can grab a drink.
Okay.
It's so great to use Redux.
Well, water.
Oh, water. I'd be good for that.
It's so
Water.
clear.
Oh, yeah.
Just a bunch of things just
We had, we were using a contract for all this stuff.
that was crazy like that.
Yeah.
So we basically got till 8, right? I mean, I don't have to rush.
No, I think that's fine.
Okay.
Yep.
Well, this thing only takes 15-20 minutes, but we can talk about anything and everything.
Cool. Middleware, they overcomplicate. So
Are we set to go, or do you have a little prep?
No, we're set to go.
Okay. Thanks everyone for coming. So my name is Micah Godbolt, and I've been with Microsoft for the last year and change now. I was actually in Redmond for this last year when I first got hired on, and somehow weaseled my way into a remote position, which is kind of like the golden ticket at Microsoft, you know, to fly the coop. Like, how do you do that? And actually, the answer of how I did it was I got involved in this project. This is kind of one of the main reasons that I went to Microsoft was they were building and are building, currently building, a UI framework built in React, in TypeScript, called Office UI Fabric React, obviously this version. And this is what I was interested in coming to Microsoft to work on. I'd done a bunch of design system work before that, spent a few years at Red Hat, building up the design system for their front end. But with that, it's literally just a marketing website with tons of content. So we've got just different card UIs and different carousels and just everything needed to display massive amounts of content. And I spent a number of years building up a new UI framework for them, new deploy processes, new build processes, new prototyping processes. I also worked in Drupal. I worked with Chris. That's kind of the funny thing. We ended up together. We were both at phase 2. I was with phase 2 when I was at Red Hat. So yeah, spent a good 2-3 years there, literally ripping out the rendering engine of Drupal and replacing it with something custom because we hated the way it rendered. And it was a beautiful outcome. So it was a lot of fun. So went about doing that work. Ended up writing a book. If you're curious, fea.pub will get you there. Called Front-End Architecture for Design Systems with O'Reilly, and had a chance to speak about that various places, and was kind of what led me to talking to Microsoft and then being interested in bringing me on. And so when I came in, I was working with OneDrive and SharePoint, which is kind of where this UI started, and was working with them, spent a good year or so, helped them build up components, build up new testing, build up better documentation, better components, better componentization of some of the larger components we had. and did that for about a year or so. And then an opportunity came up outside of OneDrive SharePoint to work inside of, which is now called the Business Application Group in Microsoft, which is kind of a big conglomerate of all of their like business apps, like Power BI, Power Apps, Azure Shell, kind of all the things about grabbing your data, taking your data, munging your data, doing cool things with your data. And as it turned out, like this humongous arm of Microsoft was all wanting to get under a single umbrella, which was what the Business Application Group was about. And also they wanted to use a single UI framework for all of their, which at the time were very disparate applications. So they're like, hey, this Fabric thing is really mature and really doing well. We'd love to use that. So as they had an opening and I just randomly applied for it, it turns out I was probably one of the more qualified candidates to do what they wanted to do, because they wanted to basically integrate this into all the products. Because at the time it was in OneDrive, SharePoint, Outlook, it was going into Word and Excel online, Visual Studio. It was starting to get in a lot of those kind of Office 365 products. But getting this whole nother set of applications, there's lots of new developers that weren't either familiar with React or especially weren't familiar with Fabric. And so I've come in to kind of work as I consider myself a design system evangelist or design system advocate, really, about trying to make sure that they are successful as possible using this UI framework, and then also to bubble up feedback, suggestions, problems that they have with the framework to try and make it better for all the other developers. So it's a pretty neat place to be, working on a single framework that's being used by that many applications, that many developers. The other unique thing about this, you might be surprised that you can go to this URL today. You can download this code today. This is GitHub. This is completely open and open source software. We do all of our building, all of our dev work here. If you want to look at our most recent pull requests, you can go see what those pull requests are. This isn't just a place we push code when we're done with it. This is a completely open source project. All the work that we do here is done by a huge team of people from all over different products. And this is not something you typically would find at Microsoft. We're having people from Outlook and Visual Studio dive on a call together and try and debug something, like working side by side without killing each other. It's like, that's kind of an amazing feat, because 5 years ago they probably would be killing each other because they'd be fighting over who gets the better software. So it's been a really neat project to work on. Basically an open source project inside of a company the size of a major city. And what I want to talk to you today about is, for one, obviously TypeScript comes from Microsoft, so we are very highly invested in TypeScript. So I want to talk to you a little bit about some of the things we do in TypeScript and the way that TypeScript influences the work that we're doing, but also just to give a quick demo of Fabric React, what it can do and how it helps the average developer out. Assuming not everyone here is, knows TypeScript inside and out, knows React inside and out, knows UI frameworks inside and out. So we're going to do a quick demo of how you can build an application with Fabric React in a very short time. So hopefully you have URLs here if anyone wants to get to it. You can just Google it. It's one of the first one that comes up as well. So I heard someone, I think you over here were talking about the Create React app. There's actually a let's talk about that real quick. Create React app. It's that one. Is a great project that's come straight from Facebook and the React team that allows you, with a single command line option, to scaffold out an entire React application with all of the linting, with all of the Webpack configurations, with all the build tools and testing tools, and all of that kind of stuff. I was talking with someone earlier today that was frustrated at Webpack at how much work it took to set up, and why weren't there just sane defaults? Here's sane defaults. If you want sane defaults, here you go. Microsoft recently, actually, a bit of a coup with Webpack, hired Sean Larkin, one of the main contributors to Webpack. And I know I've talked to him at length and heard his tirades on Twitter and whatnot, that once you start opinionating something, you lose the flexibility of it. So what we need is more stuff downstream, like this project that says, hey, I have an opinion about how to use Webpack, and here's a great way to do it. So if you're frustrated with all the amount of setup it takes, or like, oh, I wish I had that power of Elm with just a single install, this kind of application does allow you to do that and get scaffolded up really quickly. And as you're talking about the whole concept of ejecting, when you build this, it's kind of this safe little playground that you can't really mess with too much. But you can run it really just has like one node dependency, which is basically this, I think, maybe React as well. But then you can also eject from it, which basically gives you the entire application, all of the build files, all the script files, a full package.json with all of the packages to upgrade and add to as you need to. So it's a great place to start an application or just to toy with one. You can also create React app TypeScript. If you Google this up, there's a couple options here as well. Microsoft has one. I was actually suggested by another Microsoft employee to try this one out as well, from WMonk. Basically, if you want the same thing, but you also want TypeScript in the mix of it, there's a build app for that as well. So this is all prefacing to say that what I'm going to show you in this demo, I've already done all of this. I've installed this as a global dependency, create React app as a global dependency, and then you run create React app, you name your application, and then you can choose the React scripts TS, this guy right here, and then it'll automatically add in those extra bits for TypeScript to get you up and running with TypeScript compiling and checking and all that kind of good stuff. So that is, React scripts TypeScript. So super powerful if you just want to try something. It'll get you 99% of the way there, and you can start building an application. So when you build an app, you're basically going to get something that looks kind of like this. It's going to have, and I think I've ejected from this one. So once you eject, you're going to see a lot of this, like all the Webpack configuration, Jest configuration, all of these scripts for build, start, and test. So a bunch of these built-in things that you really don't need to mess with until you start, like, really want to configure it or customize it. So we're not going to do that today. We're just going to work with what we have, and we're going to build up a pretty simple application. So once we're in here, I think it probably automatically npm installs for you. So with an npm start, it automatically loads up Webpack and Webpack dev server, and is going to give us and loads up the browser, and gives us our application right inside the browser once it finishes. Go Webpack. Hi. All right, so there's our application. We rendered React to the DOM and said hello to us. Actually, one thing I guess I didn't note. So here's in the source, you can see that we do have our app file there, which is app.tsx. So we are using TypeScript files. That obviously gets converted through TypeScript into JavaScript and down the pipe till we actually have a JavaScript file at the end of the day. So yeah, that's all we're going to deal with. And we're going to add some stuff to that. So so far all I've done here is I've imported Fabric from our Office UI Fabric React. I guess the one thing I did skip, I did install Office UI Fabric React and made sure to have that as a dependency in package.json. That one. Way too much stuff in here. Hey, Office UI Fabric React. So there we go. We've got currently at 5.13. And from there, we can then start pulling components from it. So one thing we've made real specific to do is we actually export every single one of our components separately so that you can take a dependency just off the components that you need. Webpack is getting better with some of its tree shaking, but if you, actually, sorry, I'll do this correctly. Lib fabric, right? Yes. So you can pull it directly from that Fabric export. So if you only need just one component, and let's go ahead and do this with another one. Say like, what am I going to use? Well, buttons can be the first one. So you can pull from our button component just that single, did I spell it right? Yeah, there it goes. Oh, I'm not using it yet. Yeah, that's right. Like, what's the squigglies for? So you can pull that directly from these components. So you're just pulling in the pieces that you need, and you don't get the entirety of the application pulled along with it. For this demonstration, I'm just going to do it via single line. But there's one nice thing with Fabric is we do export everything as individual little component packages so that you don't have to worry about pulling in the whole thing. So yeah, so what I've done so far is I've wrapped in my return statement, who's used React? Is it pretty Okay, I won't assume anything then. With React, especially if newer versions, when you're using ES6 to do it, we're able to create a class. For every component is basically composed of a class that you create. In this case, we'll just call it app. And then you're able to extend some other class. Usually it's just a React.component, but if you have your own component inside of your library that you want to continue to extend so you can have some common functionality between all your components, we actually do that inside of React or inside of Fabric. So every time we create a new component, we get a couple built-in helpers and a couple things that we know every component needs to have. So this extend is really nice. And then into that, we're going to pass the interface and the state for that. So in this case, at this point, we don't have either of that. We don't have props and we don't have state, but that's where you would pass those in. Inside of this class, right now we just have a single render function, and that render function is what this component prints to the page. And you can see right now all we're doing is we've got this React component that we're passing the word hi into. And if we can do any valid HTML that we want in there. Valid HTML. Hey, it's got extra padding on it because it's P. All right. And you can pass anything into that. So that's basically your template area. So any markup you want to put and have that component be able to output, that's where it's going to go. As you can see what I'm doing here, you can also render other components inside of that. So we import this Fabric component, which I'll explain to you in just a second why we have that. And then we can actually render that Fabric component with other things inside of it. So that's kind of that's the React model of creating these components and then combining components together, having components use other components, and so on and so forth. Just for if you're curious what that React component is doing, that's too big. It's a real simple wrapper that I think we initially had some styles attached to, and I don't think we have as many styles attached to it any longer. But it does one really handy thing for us right now. Let's see, does it have some styles? Yeah, it does like our basic font family, font size, font weights, colors kind of thing. So that's kind of like our body tag in Fabric. But the really neat thing we do with it is you can see on the set of classes there, just MS Fabric and app right now. But as soon as I hit tab, as soon as I keyboard around inside of the app, you can see this is focus visible class show up. And this is something that we've done at this point to make it easy for us to be able to hide and show focus rectangles. Because on a button, if you're, and you'll see this when the app, when I bring the app in, on a button, you want to show that focus rectangle when you actually focus to it with keyboard management. But when you click on it, it's really not something you need because you already know the mouse is right there. So this is something that if you see, and once I click on the page, that class disappears, and I tab, it comes back. That's the way that we can hide and show all of our focus rectangles based off of how the user's interacting with the page at the moment. So really handy for us to be able to still support all those focus rectangles without just mucking up the entire UI for someone that's actually using a pointing device. So yeah, that's that. Now let's take a look at what we can do with this application. Change anything? Sorry, I wasn't supposed to change anything. So let's go to step one. So in step one, I'm going to bring in a new component called the text field. And I'm going to create a new interface. We talked about this in Elm just earlier about creating these interfaces. This is how it would look inside of TypeScript. So we've got a state interface of I2do-state. And there is a text value, which is optional. And at this point, this text value is I think maybe it could have been a string, but I'm not going to mess with it now. And then we can pass that to do state as the state of this component. So it knows what its state is whenever you refer to this .state, which we will write down here. And so once we bring these components in, we now have a text field that has properties to it, such as label, on change. We've got a ton of like random stuff on it. What was one I was thinking? Decorator? No, description. What was it called? Now I can't remember what it's called. Components. Let's take a look at it.
text field, right? So in here you see all of, let's get through all the examples. Here's the interface for it. Here's the props. So we've got past class names. You can create borderless descriptions. You can pass in icons, labels, so on and so forth. We also have some methods here for callbacks for on change and whatnot. I thought there was something else. Anyway, so we could have, what was it, description? So we could bring a description in and do that as well. And then here's, so as I said, we can also pass in those callback functions. So anytime the text field changes, it's going to execute this function. And we know that the onChange takes a text, takes a string of text, and returns. Actually, doesn't return anything. Let's see right here onChange. So it takes a new value and it doesn't return anything. It's a void return. So we just can take that text and pass in the state, and we can update what that state is based on whatever the text is we pass in. So let's see what that looks like real quick. Hey, here's my description showing up below. If you haven't used React, you might not know about React Dev Tools, or Chrome, I think they're what, React Chrome Dev Tools, whatever they're called. But this is a way that you can actually inspect your application. So if we want to see, like, what's that, what does that state look like as I change it? So you can see as I change the text, it's actually updating the state inside of our application. So this is pretty common with what are typically called controlled components. So the notion that we're not just going to put text into this field and then try and grab the text from the field from elsewhere in the application. We're actually going to take the text that's in it and push that up to into the application state, into that the state up at top, so that later on when we need to get to it, it'll be really easy to do so. So that's adding a text field. Oh, that's not going to work because I need to. Any questions with that? Got a little time, so I'm happy to dive into a few more of the pieces. Oh, all right. Sorry, I didn't save things properly. So let's take a look at step 3, or step 2. All right, so we know that we've got a text field now that we can put text into, and that automatically bubbles up to, is this a little better? That's probably a little better. And we know that's going to bubble up to the state. So we always have the state that has a value of, state that has text in it that we're able to get to anytime we want to. So what I'm going to do now is I'm going to go up here and add primary button. We're going to pull that in. And primary button takes a couple different things. It takes icon props, it takes some TDX, some text, as well as an on-click function. So let's take a look what that looks like. That's definitely too big. That works. So we can type into here, and we can click on our to-do, and then on-click, I just had to do a quick console or a quick alert, so we can see that it can take that value, whatever you have in the to-do, and pop that up into an alert function or whatever we're going to do, which we'll do here in just a little bit. So as you can see, really what I'm trying to demonstrate is the Fabric as a UI framework allows you to build these interfaces with a very small amount of code. There's really no glue code that you need to make except for just handling state within your application. All these controls are pre-built. They look nice. They're compliant with the rest of kind of the Office look, and they're going to give you a lot of functionality right out of the box. All right, so let's jump to the next.
How many states could you have?
Really, it's unlimited, the amount of states. Like if you're talking about up here, is that what you're saying? Like having other values?
Set state, like put the text.
Well, at least with TypeScript, you need to specify all your states up front. So you need to specify. And I'm going to actually I'll jump to. Let's jump to state 3 because I did that. I need to add another one. So we've got text, and what I'm doing is trying to create a really simple to-do app. And what I want to do is whenever I click enter, I want that to do whatever that value is to go into my to-do list. So what I need to do is take the value from text and move it over into to-do. So I need 2 states, so I can push the other one over to that. So if you do need a second item in state, that's exactly what you do, just add that to the interface so the component knows what it actually has on its state. So a couple other things I've changed here. I brought a checkbox in. I've got a constructor on here because one thing I need to do is I want to make sure I want to set the value of that to do before the application starts, so I don't have any functions or anything running that might go like, hey, there's no value there, and blow up. And I know we talked about nulls, but I had a null in here, and I'm sorry. You could probably, I think I did this just try and keep it as simple as possible. I'm sure you could do like an empty string or whatever. There's other ways you could do this. And again, this is a to-do app where you only have one to-do, so don't think this is production code. Trying to do something very simple, something that's you can show within 100 lines of code. So so I've done a couple things. Now whenever we click, I've got a new function, this add to do, down below that I can pass that text into. So remember that text we can grab from the state. That's whatever you type into the input up above. And then we can pass that down to a function. So let's look at what that to do is. So add to do is a function that takes a to do, which takes a to do which is of type string. There's no return to it because it just mutates state. So that's why we say void. And then here is us mutating the state. So this dot set state will set the state for the global state of that component. And then this is actually a little shorthand. We're throwing an object in here. And to do is the property that you want to set the value to, and to do is also the name of the value that you want to pass to it. So with JavaScript, it's kind of nice. You can just pass it in. Which often happens when you have a variable with the exact same name. So it simplifies your code quite dramatically when you have lots of those. So we're able to set that state anytime that we hit enter on this primary button. So let's see that in action. Oh, that's what I want. There we go. More to-dos. And you can see, so here's this keyboard rectangle stuff. So you can see that the focus rectangle shows up on that. But if I click on it, it doesn't get a rectangle. So that's that rectangle only shows up when that class is added by that fabric component. So you can see that we have added that to state. Oh, here we go. Yeah. Let's get rid of this and look at our state again real quick. So you can see now we have got a to-do of add more to-dos, and the text, I probably could have cleared that out, but you can see now I can change this to be something different. So we've added this to-do down into that checkbox, and we can look how that works. So you see the checkbox didn't actually show up until we had a to-do. Let's refresh this. So there's no checkbox here at the moment until we actually add something. And now the checkbox shows up. So this is what else we can do, where we can programmatically show or hide content on the page based off of our current state. Oftentimes we do this with styles, like you'd flip a class from is hidden to not hidden and so on and so forth. But with React makes it really quite easy, where you can actually either render the DOM or not render the DOM based on that. And oftentimes that's the better way to do it. And also React is very good about making that clean change of pulling that small bit of content out or pushing that content back in. So in this case, what we're doing is we've got a so this is kind of this is the JSX portion for people that aren't familiar with React. Is that this is all HTML, HTML, HTML. I guess this is kind of funky. It looks JavaScripty. But then down here, we're breaking all out of HTML. We closed up this last tag, and now with these curly braces, we're actually dropping markup on, or dropping JavaScript right onto the page. So this .todo.state is basically it's a Boolean check in this case when you have that double ampersand. I could actually probably be a little stricter if I did that, but either way. So if this is true, in other words, if it's not null, if it's not undefined, if it's not false, and render this, it's an interesting thing because it checks two things, but then doesn't do anything else afterwards. But in doing the second thing, in rendering that checkbox and getting a non-null response from it, you've got what you want, which is that actual checkbox rendered. This is a pattern that we use pretty often, rather than doing if this is true, do this, otherwise null. So So it cleans up a lot of those as well. So we, if there's a to-do, we can render this checkbox, and the label is equal to whatever we pass in the to-do. And then the checkbox has a remove to-do function attached to it. So anytime that checkbox changes, anytime it changes from non-checked to checked, and honestly, this, if it went from checked to unchecked, it would also do it. Again, simple application. It's going to go down to here into the remove to-do app, or remove to-do function, which again takes it takes nothing as an input, and there's no return. It's just going to set our state to null. I could have written this even inline, but just breaking them down here makes it a little bit cleaner. So you can see that when we click on this, it's going to disappear. Because once we clicked on it, it set the state of the to-do to null, which cleared out the state. But because that state changed, it reevaluated anything that depended on that state. So the checkbox only shows up when that to-do is actually present. So it automatically disappears for you as soon as it does that. So there's a lot of things that both you get from React, being able to show and hide content on the page, as well as from Fabric, and being able to have all these components already pre-built, already accessible, with all of these properties already built in. So one more, these are pretty basic constructs. I'm going to add one more in here. Any questions before I move on? We'll see more of this in just the next one as well. Let's take a look at step 4. Oh. It's a problem when you do that and you start typing. Hey, there we go, step 4. So I brought in progress indicator, and I think that's all I need to do. Yeah, so progress indicator is a component that lets you indicate the progress. So this is one of those components that's not a simple button, not a simple input. It's something visual that every app that's worth its salt or has something like this, a to-do app of any sort, is going to need something like this. And one of the goals of Fabric is so that for all those applications that over and over and over again need some construct like this, they don't have to go and build it themselves again. They don't have to build the logic. They don't have to build any accessibility issues. They don't have to figure out the styles from the designer to make sure that designer talks to other designers to be consistent. We give you the components that you need to build the application that you need to build. So there we go, back to here. So take a look at what this progress indicator takes. It takes two things. It takes a label. Actually, it takes more than that, but two things we're passing in is a label and a percentage complete. So let's take a look at this label real quick. I've got a template string in here, template literal. These things are popping up all over the place. I need like use the pointer or something. Which we're taking this state to do, and here I am doing this ternary. So if there's a state to do, then I'm going to return 0% because we have 0% done. If there's no state to do, as in all of our to-dos are finished, I'll return 1 and then just multiply that by 100. I guess I could have done 0 or 100, whatever, doesn't matter. And then I'm going to concatenate that with percentage done. So you can see right here, 100% done because we don't have any to-dos. And then if I do a to-do, you can see it goes back to 0% done. So just nice, simple way to continue to be able to use that state. We don't have to add any additional logic to that component. We don't need to have to formulate the strings by ourselves. We can just use what's available to us in state to automatically spit out what we need. So same thing with percentage. It's pretty much the same logic, just for something slightly different. Percentage takes a number, and let's see if I can go to it. Percentage complete. Yeah, just in this case, it's a number. If you look at documentation, it'll probably say number between 0 and 1. Does TypeScript have a between 0 and 1? No, that would be nice, wouldn't it? So that's why it's just a number and not something more type safe. So if to-do.state is null or undefined, then we're going to get a percentage done of 0. And if there is a value, we'll get a percentage done of 1. So you can see if I do this at like 0.5, this will actually go 50% of the way, just that kind of thing. So back to that, over to that. And you can see built-in animations. I think we even have a vertical version of this as well. So there's a lot of built-in functionality that you get from these components that you don't have to write a single line of HTML. You don't need to write any additional CSS. You really don't need to write a bunch of logic. You just need to take this UI and pull it into the application, figure out your state, figure out how you're dealing with state. We really don't care, but it allows you to scaffold out and build out your applications really quickly. So that's really mostly it. So yeah.
Is there a global style sheet that you're referring to? Or is
In this case,
part of the component?
Part of the component, yeah. The fabric wrapper has a couple of just like the basic, as I said, like font family, font size. This is the kind of default color. But if you're curious, there's a bit of a mix because it's a project that's in flux. If you look at progress indicator, there we go. You can see MS Progress Indicator - item name is the class name for this div. You can see the styles. Does anyone have a guess as to what that is?
I was just going to ask you, so you don't have it where you can define the office themes?
Not here necessarily. There's a way to theme them, but that's not built into this framework. Okay. So basically, the approach that we were taking with Fabric is. Fabric is a very unopinionated framework. We don't know the application you're going to be using it in. We don't know the context you're going to be using it in. We're not going to build in, here's all the Office themes, because that is obviously not going to make a lot of sense if it goes over to Azure where they're not doing Office themes or something like that. That's not complexity or weight we want to do. But what we want to do is we want to be able to support them be able to retheme the application any way they want. And we do have there's some kind of couple different ways to do it, and they're a little bit more long and complicated, but what we want to do is support being able to pass a custom theme in. So yeah, every component can take a theme object, which is basically a remapping of our standard variables. And then we have got some more customizable ones as well. So again, you're not going to find all of our themes in there because we don't know what themes people want to use, but we do want to make them themable.
Looks like a commit shop.
It's very close. It's definitely a shop. This is CSS modules. Anyone use CSS modules? Are familiar with it? All right. The idea behind CSS modules is who uses BEM for a syntax? Like BEM, or you have block element modifier. At least one. Oh my gosh, not the right crowd apparently. So the BEM syntax is basically the idea that global CSS is horrible because you have all the CSS flying in all over the place. You never know what something's going to be styled, and you got CSS coming from over here, and you're like, but I don't want that CSS, so you have to write an even more specific selector to overdo that one. It just becomes specificity battle to try and get anything styled properly. So what BEM syntax does is this is BEM syntax right here, literally, because we actually started with more of a BEM approach. Let me just pull this out and take a look at it. So this is BEM syntax. Oftentimes you'll have a prefix, so your class names are different from Bootstrap, from Foundation, or any other thing that comes in. So that's the first thing that separates your styles from everything else. And then you're going to have a block name, or a block value. So the B in BEM is for block. So what is this component's name? And let's scope all of our styles inside that component name. And then the E is element. So we've got a progress indicator, and then item name is this one element inside of it. So we know that the styles for the progress indicator item name inside of the Microsoft project is going to be a very specific and unique selector. And that's the only selector that we use to apply styles to the component. So everything's flat, just a single class. You can use that inside of a global scope. And you're pretty confident that's not going to mess with anyone else's CSS or anyone else's HTML because of all that scoping. And you know that it's not going to mess with other components. You just don't have item name in there because who knows who else is going to use item name. But there's only one progress indicator in your project, and you know those styles are specific to it. And then if you have a item name and then you have an active item name, you might throw a M modifier onto that as well. So you have an even more specific class to be able to apply, or an even more unique class to be able to apply to your component. So that's BEM syntax. Is the idea that every single class name is highly specific they're long and kind of nasty, but they're also very explanatory. Like, you know exactly where that came from. You know the component it came from. You know what element that's applied to, and you know which variant that one's being applied to. So it's very declarative in that. So it works really well to be able to look at markup and go, oh, this is the progress indicator item progress. Oh, cool. That's pretty obvious what that is. But what it comes down to, though, is BEM is really a hack. BEM is a, what's the right word, a encapsulation hack. It's by giving this really specific block name, I ensure that all the styles that I write for this component only affect the component. If you ever worked like within Shadow DOM and those types of things, that's the same idea of this encapsulation. Like, what if you could just say .item instead of, you know, .ms dash blah 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 .item? Like, what if you could just say .item and just style it that way? It would be a lot easier if you didn't have to worry about .item going out and polluting the rest of your DOM. So this whole encapsulation thing is what we're trying to solve. So this is a long explanation for how do you style things. So what we do with CSS modules is the process goes, we have, let me just get to it and I can show it really quickly. Oh wow, time flew fast. I'll try and wrap up. So the progress indicator, we have a SAS file for this. It's nothing special, nothing crazy, nothing fancy. If we go to progress, SCSS, hey, look at that. So we have a SAS file for this. Merc, all these kind of things. So, oh, properties table. It would help if I got the right thing. Progress indicator. There we go. That looks more like what I was expecting. Item name, these kind of things. So we have a SAS file. And through Webpack and the joys of that kind of process, what CSS modules does is it pulls pulls the SAS in, converts it to CSS, and it looks through this entire structure, root, item name, item description, and creates a map of all of these values. And it looks at the styles that are inside of it, and it creates a hash based off those styles. So what we're seeing here is, even though we've got item name right here as a class name, and when you go into the progress indicator here, and we go to item name, is that what it was? Yeah. And even though we're passing item name in as a class name, what's actually happening is it's automatically creating that hash when it builds, so that what we actually get is item name underscore some hash. And again, that hash is based off the styles that are down below it. So if we change those styles, it's literally going to change the hash. What this solves is not only this encapsulation thing. Like, we can just call it item name, and we don't have to worry about this big long ms dash blah 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 blah. It's just item name, and it makes it really declarative inside of our CSS. So that gets us this encapsulation thing, but it also saves us from what happens when you have two item names on the page, one from version 5 of the framework and one from version 6 of the framework. And you're like, hey, that's never going to happen. Yeah, try working in SharePoint. It happens all the time, because SharePoint runs on one version, and then someone brings an add-on that's using a different version of it, and now those have to live on the same page at the same time, and you don't want old versions of whatever they bring in messing with, again, your global scope. So since this is hashed, we know that if the old version had line height of 16 pixels, it would have a different hash. And that class name would not be the same as your class name, and you wouldn't be affected by those styles. So that was the solution that took us a long time to get to, that allowed us to be able to have multiple versions of our framework on the page at the same time without resorting to iframes or any other craziness like that. You have a question?
I was going to say, it's also called cache busting.
Yeah, exactly. The cache busting helps too, so you know that value is in there. The other nice thing is, if you do have this multiple times with the same styles, it's going to be the exact same item, and that can easily be pulled out. So if you're if you're afraid of too many of these things being generated, if it's exact same styles, it's going to be the exact same thing on the other side. Now that's one thing that we have, because we've also moved into what happens if you want to have two things on the page. What if I want two buttons on the page? And actually, I can even just do this. let me get back to the right project. Here we go. Say I want 2 buttons on the page, and I want them both to be primary because I don't want to have to mess with something different. But I want the background of it to be different because I'm a designer and I want the background of the button to be different, or borders or whatever. So the buttons actually take roots, background, red. How about that? That looks good. Hey, I've got 2 buttons on the page, the exact same component with different styles. And I'm not doing that by inline styles. So I can even do hover stuff in there if I need to. I'm not doing that by more specific class names, so I have to like battle with specificity. I'm literally on the fly creating a brand new, let's see if I can find the other one. Here's the 2 buttons. Yeah, here it is. Let's look at this. Yep. I'm literally creating 2 different class names. One's CSS-34, another one -45, that have different styles to them. One has blue in it, one of them has red in it. And the way we're able to do this is through CSS and JavaScript. So that's literally the only way you can do this. So this happens at runtime. When I render this button onto the page, it looks at all of its props and goes, hey, I've got some additional styles that need to be mixed in with the default styles. So when I render the, and I hate this is so long, it's hard to see it. When I render the background value, don't use the regular value there, use this other value instead. And again, the only way you can do that is if you actually burn the styles onto the page through JavaScript. And so what that allows us to do is any button that you need on there to be something unique, custom, one-off button. You don't have to go and overwriting styles. You don't have to try and find a class name that's more specific. You don't have to try and inline things and mess up all your hovers and pseudo elements and everything. You can style them with that same interface that we're actually style them in the component. And obviously that's just a button, but you think like a calendar or something like that, where you want to like customize the size and the shape and the colors of the entire calendar interface. You can completely retheme that just with a different JavaScript object. Because as you can see, this one, this is just a JavaScript object. So you could have that JavaScript object in some other file, require that in, drop that in, and have your customized calendar experience with like that. And not have to worry about, oh, the specificity changed and all my styles broke or something like that. So for us, that's been a really powerful thing for us to be able to do, of have multiple components on the same page with not only be able to change the theme of the page, but even the theme of per component. So again, long answer to your short question. So it's 8:01. Are there any other burning questions that you have? If you have further questions and just don't want to ask them now, please catch me on, oh, come on, where I can type, on Twitter, at Micah Godbolt. Certainly feel free to ask questions, tweet at me. I think my DMs are even open. More than happy to answer questions about this. This is open source stuff. If you're curious how we build this, like how things are put together, how the TypeScript works, you can git clone it, you can run it, you can do everything I just did here. You can do a pull request. If you see a bug, please feel free, do a pull request. It's open source, yeah.
The SCSS file, is it compiled by the Webpack?
Yeah, there's a Webpack loader that's, when we go back to, where are we at? Progress indicator, when you go back to the top here, we're going to see import as style sheet from this guy right here. And there's actually a little wackiness we had to do here to get type safety on it. Now we have const styles of type any that equals the styles import, blah, blah, blah. But you can see that it has this import statement. And so Webpack will go and see that Sass file, turn it into CSS, bring it in. I think there's even a CSS modules as well. So it brings it in. The component is what then takes that and burns it onto the page. So there's a style tag rendered to the page along with the markup. So whenever you pull the component in, you're also pulling the markup in as well. And then at that time, it's able to determine the hash and all that kind of stuff. But since all the styles are still in Sass, all that's doing in the component is just doing the hashes. It's not going in and trying to change values inside of that. Maybe you could, but what we do otherwise is like for our button, it's pretty. Our button is huge. It's kind of crazy. So here's our styles file. Is literally a TypeScript file that has, again, root with a bunch of properties. So I mean, in the end, we're pretty much writing CSS as far as like, here's a color and we're pulling it from like a variable. Hey, it's just like Sass. And in the end, at the end of it, you're still getting a style tag with CSS selectors and properties inside of it. It's just how do you want to store that? How do you want that basically a rendering pipeline to work? Because if you start in JavaScript, you can then mess with it before it actually gets to the page. Any other questions? Great. Thank you so much for my short 20-minute talk.
Thank you, everyone, for coming. Hope to see you in November.
You too.